Hello, everybody, and welcome back. So we're going to get into lesson 4 now. Welcome back to Math Zone African Motifs. So for lesson 4, we're going to do an exam type question. Okay. I have a question here from, So we're going to do question 5 together. This is question 5. And it's from Northwest, November 2024. It's based on energy and change. So let's get into the question, okay? Say what? One of the steps in the preparation of sulfuric acid in the industry is represented by the following reaction. The graph below shows the energy change during this reaction, okay? And then, so we see here, this the potential energy, and it's measured in kilojoules per mole, the reaction coordinate, okay? And then 5.1, they say write down the type of reaction represented by the above graph. Choose exothermic or endothermic. And then they say, explain your answer, okay? So 5.1, what type of a reaction is this? Okay. Meaning that the reactants will be there, and then we follow the curve until it ends, and then you have the products here, okay? So 5.1, the answer here is what? It is exothermic. 5.1. Exothermic. And then what is the reason here is that what? Energy of the energy of the reactants is greater than energy of the product. Yeah. Is greater than energy of the product. Or you could say what? That the enthalpy here is less than 0. So you could give one of the two reasons. It doesn't have to be both. And then 5.2, what are they asking? Calculate the enthalpy change. The change in enthalpy for this reaction. Again, we have to look at the the enthalpy of the products. So the change in P here is going to be H E minus H R. So now we go to the products. For the product we have negative 86, and then for the reactants we have 25. So it's going to be negative 86 minus 25. Okay, so it's going to be negative 100, and you use a calculator here. It's going to be negative 111, and then it's what? Kilojoules per mole. It's kilojoules per mole. That's what they gave us here. And then they say vanadium pentoxide is added as a catalyst in the above reaction. How will the addition of the catalyst affect the following? Write down only increases, decreases, or remain the same. How will it affect the activation energy? We know that the activation energy goes down, isn't it? The catalyst decreases the activation energy power. So the activation energy decreases, isn't it? Decreases. And then the heat of the reaction, the enthalpy. So the catalyst has no impact, it has no effect on the heat of the reaction. Okay, so it will remain the same. Remain the same here. So there wouldn't be any change. So these are just, it's 1 mark, 1 mark, 1 mark for 5.3. The heat of the reaction is not affected by the catalyst, so it won't have any impact. It will remain the same. And then they say at 68 kilojoules per mole, an activated complex is formed. Define the term activated complex. Okay. And then they're going to say okay. So at 68 kilojoules per mole, an activated complex is formed. Define the term activated complex. Okay. So 5.4.1, they want the definition. Okay? The definition for activated complex. What is an activated complex? So activated complex is the unstable transition. Is the unstable transition state from reactants to products. Okay, so and then 5.4.2, they say write down the activation energy for the, okay, so they want for the reverse reaction. Okay, for the reverse reaction, it means that if we go from the reverse reaction, it means that now the reaction is going that way, meaning we go from here and we go that way. So meaning the activation energy will be from here all the way up to the, okay, this will be the EA, the activation energy, if we are looking at the reverse reaction. So if we want the activation energy, it means we have to minus 68 minus negative 86. Okay, so now 68 minus negative 86. Okay. So the two negatives will become a positive. So plus 86. So it will become, you use your calculator there, be 154 kilojoules per mole. That is the unit that we're given here. It's 154 kilojoules per mole. Yes, that is the unit that we're given here. Okay. So now they're saying 5.5, calculate the volume of sulfur trioxide gas formed in the container when 50 cubic centimeters of sulfur dioxide reacts completely with oxygen. Okay, now we have to look at the ratio. And we have to look at the what? The ratio. Sulfur dioxide and sulfur, they have the equal ratio, isn't it? 2 and 2. 2 and 2. 2 and 2. Okay. So it means that if you have 50 here, you will also have 50 this side. You see? So if it means that 50 cubic centimeters, okay? So it means that volume for what? Sulfur trioxide produced, okay? Produced will be equal to 50 cubic centimeters because they have the same ratio. You see? So therefore, we just use the ratio of the two things, sulfur dioxide and sulfur trioxide. So if they have the same ratio, it means they'll have equal volumes. So if they tell us that sulfur dioxide is 50, okay, it means that sulfur trioxide will also be 50. Okay. It's because they have the same ratio here. The ratio is the same as 2 and 2. So that's it. Okay. So guys, this question was 12 marks, you see. So you can see that the questions are usually something like 12, between 12 and what? And 15 marks. They are usually around that range. See, it's not a lot of marks in the question paper, but then that doesn't mean that you should take this topic for granted. You see, because that mark, those marks could save you somewhere, isn't it? So yeah, guys, let's leave it here. Let's leave it here for lesson 4. Okay. Thank you for tuning in. So you must stay tuned in. Okay. I hope you come back for lesson 5. We're gonna do more questions. Okay. So guys, please leave your questions in the comment section if there's something you want me to clarify. Okay. So keep the engagement going in the comment section. Feel free to ask questions. And then if you don't understand something, I will clarify. Okay. Thank you again for tuning in. I hope you tune in for lesson 5. Take care.